Hello and welcome back. In the last video, we talked about how we can use substitution to solve a system of linear equations. We did one example where we had one equation in point-slope form and another in standard form, and another example where both equations were in point-slope form. There is another method that we can also use to solve systems of linear equations, and that method is called elimination. It is normally going to be used when we have two equations both in standard form. So for example, we can have the two equations 4x plus 8y is equal to 16 and 2x minus 8y is equal to 8. So I'm going to write these equations again over here, and then what I'm going to do is add these two equations together. You'll notice that 4x plus 2x is 6x, 8y plus negative 8y is 0, and 16 plus 8 is 24. That gives us 6x is equal to 24. Now notice what we did. We eliminated the variable y, and that is now going to allow us to solve for x. So from here, if we want to solve for x, we have to get rid of the 6 next to the x. We will divide the left-hand side of the equation by 6. That means we have to divide the right-hand side of the equation by 6. These terms cancel out, and we have x is equal to 24 divided by 6, which is 4. So there you have it, x is equal to 4. Now all we have to do is, as we did before, substitute x is equal to 4 into either one of our original equations. I will do it with the first equation. So if we substitute x is equal to 4 into the first equation, we'll have 4 times 4 plus 8y is equal to 16. That gives us 16 plus 8y is equal to 16. And then our goal from here is to solve for y. We will first subtract 16 from the left-hand side, which means we have to subtract 16 from the right-hand side. 16 minus 16 cancels out, and we're left with 8y is equal to 16 minus 16, or 8y is equal to 0. Dividing both sides by 8 gives us y is equal to 0 divided by 8, or 0. So we have y is equal to 0. And that's our solution. So for x is equal to 4, we have y is equal to 0. Therefore, the point of intersection or solution is 4, 0. And that is our final answer. Once again, if you were to graph these two equations on a grid or a Cartesian plane or graph, you would find that they would intersect at the point 4, 0. Let's do one more example. We have 3x plus 9y is equal to 12, and negative 2x plus 9y is equal to 7. Now again, we want to add or subtract these equations in such a way that we will eliminate one of the variables. So in the previous example, we added the two equations together. Here we're actually going to subtract the equations, because we notice that in order to get 9y to cancel out with 9y, we have to subtract those two terms, right? So 3x minus 2x is 3x plus 2x, which is 5x. 9y minus 9y is 0, and 12 minus 7 is 5. So we're left with 5x plus 0 is equal to 5, or 5x is equal to 5. And notice again that by using elimination, we were able to eliminate the y variable, and we can now solve for x. In order to solve for x, we need to get rid of the 5 next to the x, so we have to divide the left-hand side of the equation by 5. That means we have to divide the right-hand side of the equation by 5. The 5's cancel out, and we're left with x is equal to 5 divided by 5, or 1. So there we have it, x is equal to 1. Again, from here we just have to substitute x is equal to 1 into either one of our original equations. I will substitute it into the first equation to get 3 times 1 plus 9y is equal to 12. That gives me 3 plus 9y is equal to 12. And then from there I just have to solve for y. I will subtract 3 from the left-hand side. That means I must subtract 3 from the right-hand side. 3 minus 3 cancel out, and we're left with 9y is equal to 12 minus 3, or 9y is equal to 9. That gives me y is equal to 9 divided by 9, or 1, and therefore y is equal to 1. This tells us that our solution is x is equal to 1, y is equal to 1. So our point of intersection, or solution, is 1, 1. And that is our final answer. So I went over 2 of the examples I wanted to go over in this video. In the next video, I'll go over 2 more examples with elimination that deal with situations where you can't cancel out the variables right away. But for now, as always, thanks for watching.